Bismillahirrahmanirrahim. Let us look into more examples. Okay, so this time around, we are to integrate something like this, such that this is an improper functions. The degree of the numerator is greater than the degree of denominator. So we need to simplify it first by using a long division and then diffract it into a simpler fraction using partial fraction decomposition. So let's recall back on our long division. First, when we are doing the long division, okay, for example, polynomial divided by a divisor, we get the answer, we call it quotient, and the remainder over divisor. So this remainder over divisor will become a proper fraction, degree of numerator less than the degree of denominator. Okay, and because it's a plus there, we can actually separate the integral. Okay, but first let us get this r over d, okay, and the quotient. So let's do this long division. Okay, let's recall back our math 1 work. So what times this so that we can get rid of the x? So it is getting x power 4. So we have to have x, okay, x times x power 3 is x power 4. And then the same thing, x times negative x squared, we get negative x cubed. And then minus, okay, this minus this, there's none, 0. Over here there is no x power 3, or actually there is a 0 x power 3. 0 minus x power 3, we get x power 3. Okay. Positive, right? And then let's pull down this x squared. Okay, so let's repeat the process. Okay, so we have 1 times this to get to this. So we have 1 times x cubed minus x squared. And then we deduct further, and we pull down this 2 further. So we deduct, and we have 2. So how do we write this? X power 4 minus x squared plus 2 over this. So it has to be in this format. Okay, so we have hence the q, this is the quotient. Okay, x plus 1 plus the remainder, which is 2, over the divisor, which is x cubed minus x squared. So we get this. And let's say that we are now to integrate this fraction in terms of dx, and we can do it term by term. Okay, but yet how do we do the integral of this part? Let me write back the question. It is actually only if you have a plus minus, then you can separate. So how do we decompose this? Okay, it depends on our denominator, but first we need to factorize our denominator. Okay, so here we see, okay, x minus 1, isn't it? And here we have linear and linear. So in other words, to say, if I say x squared, this is x times x. It's a repeated linear, case 2. Okay. This is case 2. And over here, for the x, this is irreducible linear, case 1. Okay, so I'm going to say this is case 2 just now. Erase this part. Okay, for case 2, how do we diffract it? How do we decompose it? Okay, it's a form of power increasing order of our denominator. Let's call the variable or the constant. The constant over there as a, so it's a power x. And because this is x power 2 repeating twice, so the numerator will receive constant and x power 2. Okay. As for this part, the factor for x minus 1 is case 1. It's not repeating. Let's call the constant as c. And it's over the x minus 1. You have to get this format read correct first. Okay, statement must be correct. Alright. So, and then we are, in order to solve our ABC, we need to compare the numerator. To compare numerator, denominator must be equivalent. So meaning, let's get the denominator equivalent, x square over x square times x minus 1. So let's set denominator for this part as this one, so that we can compare later on. So over here, a on x, we do need to have a times x, right? Let's check back. A times x over this, we need to have, x minus 1 as well. Okay, so as we cut, we get back a over x. Okay, correct. And then for this b over x squared, we need to have b times x minus 1. Let's check back. This thing divided by this thing. Cut x minus 1, we get back the b over x squared. Okay, correct. As for the c, we need c x squared. Let's check back. To c x squared divided by this. Cut the x squared, we are left with x minus 1. Correct. So you have to have this one correct first. Then only you can compare the numerator. So we compare numerator. So I'm rewriting back, compare numerator. Okay, we have this. I put down the 2 on the right side. So this is in equation 1. Alright, you have to get this correct first. Okay, this must be correct statement. Must be correct. Because your ABC depends on this equation. And then let us solve ABC. So let's use elimination. For example, they can see x. If we set it as 0, we can get the b, right? So substitute x as 0 there. So it becomes 0. Over here, 0 minus 1 is negative b. And over here, 0, we get 0 there. X is 0, becomes 0. And right hand side is 2. So hence, okay, nice. We can solve for BB. Alright, so we got 1. Okay, and then what else? We can see x minus 1. Let's substitute x as 1. So that we can eliminate here, and get the c. So let's solve it. So if x is 1, this is 0. If x is 1, this is 0. So if x is 1, we get positive c. And we got c as 2. Okay, nice. Alright, next. We have got the b. We have got the c. What about a? What else to substitute? Let's use substitution, and by using the b and c, let's play with a simple number. Let's say x is maybe 2. Okay. So let's replace x as 2 in the equation. So just now we have got the b and the c, right? So let's replace it. So here we have a times x is 2. 2 minus 1 is 1. And our b is negative 2. I'm replacing back b. Okay, so x is 2. 2 minus 1 is 1. And c, I've got the c. Let's replace it. C is 2. X is 2. 2 square is 4. And this is 2. So hence, let us solve our a. So if my calculation is correct, I got a as negative 2, right? So this is a. This minus 2 is 6. 2 minus 6 is negative 4. Negative 4 divided by 2 is negative 2, correct? After you have got that, don't stop there. You have to put down your answer properly. So basically, this is the method. You have to show whatever way that you are solving it. But yet, you have to replace back your fraction that you are so you have to write back the fraction that you are decomposed just now. Okay, so what is a? A is negative negative 2 over x, b is negative 2 over x squared, and c is plus 2 over x minus 1. Put this thing back, alright, because there's an a there for your decomposition. Okay, so hence let's come back to the question just now. So this is what we did just now. We need to replace it back here, and only if you have a plus and minus, then you can integrate separately. Okay, so here I see there's a 2 there. Okay, let me separate them, and whenever you see a constant, you can put it up front only for the constant. So this is what happens when we separate them, meaning you are actually integrating term by term, but you don't really need to write it down. You can just easily integrate term by term. Let's integrate everyone. Okay, let's check our answer. So as we integrate all, integrating x, the x we get formula x squared on 2. Okay, integrating 1 dx we get 1. Okay, and then we have to write it down back. Integrating 1 on x is ln x, okay, where the x must be positive. And here I put down 1 over x squared, which is x power negative 2. So let's put the constant first. Integrating x power negative 2 is x power negative 2 plus 1. Negative 1 over negative 1. Okay, but yet for this portion, we need to use simple u substitution, right? Let u be x minus 1, du dx is 1, so du is dx. So this portion, you have to show that you are doing the u substitution. You cannot integrate straight away. You have to show your work. Okay, what method that you are using to solve it. Here, as we substitute this denominator, we have a u, and the x is du. So you have to have this. Okay, if you don't show it, you will lose mark, and we cannot accept for your answer. Let me rewrite it back. Okay, so for this part, a derivative of 1 on u du is ln u. Okay, you should write down like that, and then replace your u. Okay, so like this. So that will be your answer, your last answer. Okay, let us give the mark. So there is a 1 mark for you to show of the long division and get to your quotient like this one. Okay, until you can get this value. Okay, for the long quotient. So the format, the equation that you have to highlight or you have to show. Okay, so the constant depends on this equation that you created. It has to be that. Show the method on how you are solving your constant and the answer for this part. As for this part, you replace back into this portion, okay, the one that we have as a fraction format. And then you have to show in order to solve this portion, you have to do the u substitution, show it, and then get the answer. So that is our complete work on this question number 1 as your guideline. Okay, get that? Okay, let us do more.